While you're watching this, you need to do a couple things. First of all, make sure that you have the note sheet out. I passed them out yesterday. If you didn't get one, you can just do it on a blank sheet of paper to get your points. Now, this lesson is worth 10 points. I'm going to call it a notes assessment because I'm gone. You'll find that when I'm gone, those of you who do the work, you're going to love it because it's so easy to get 10 out of 10 test points to build your grade. And I modify the assignment, so you should be able to get everything done in class and earn some easy test points. If you treat it as a day off, those test points go down 2 per day late. So you're just choosing to have to do it later or take a big grade hit. All right, so here we go. 2.2 notes are on conditional statements. So again, have this sheet out and fill it in while I talk through it. 5 points for this, 5 points for the Edpuzzle answers, and 5 points for the Delta Math at the end. So lots of points today, but they're easy to get. So let's start. A conditional statement is also called an if-then statement. So in the first blank on your note sheet, you should write if-then statement. If you're doing it by hand, you might need to pause the video to give yourself enough time to write these out. But conditional statements are also called if-then statements. So I have one written here right below. If I am hungry, then I eat. That's a conditional statement, and I can totally see the if and the then. Sometimes, though, they get hidden, and I will talk about that later. So under the I am hungry, the part that comes after an if, I want you to draw an arrow and write the hypothesis. So if you're asked for the hypothesis, you're looking for the statement that comes first, the part that comes after the if. Sometimes that if comes in the middle of the sentence. If I said, I eat if I am hungry, the I am hungry is still the hypothesis. Now in math, sometimes we like to use symbols. M for slope, you've been used to that. First coordinate being X. Well, hypothesis is called a capital P. So if you are asked to identify capital P, it means to find that hypothesis. The conclusion is always after the then. And that, symbolically, is with a capital Q. So I can also write this statement as if P, I am hungry, then Q, I eat. And it would look like this. Now the one after the comma here, that's even a shorter version. P arrow Q means it goes forward if P then Q. So if-then statements have a hypothesis and a conclusion. Symbolically, those are called P and Q. So let's move on to our next part. I eat when I am hungry. Now this is a conditional statement. I do something when something happens. It's conditional upon something. What do? I eat. When do I eat? When I'm hungry. So when I see that word when, I like to slash it, so you should slash through it on your note card and replace it with if. When is really, for this lesson, the word if. Then I can rewrite it as if, what comes after the if? I am hungry. Then I eat. So the hypothesis you'll see is actually at the end of that sentence, if I am hungry. I eat if I am hungry. All right, part B. We're going to talk about truth values and counterexamples next, and we're going to move into not being hungry anymore, but doing a little geometry. So here's my conditional statement. It's in if-then form. If an angle is acute, there's my hypothesis, then it measures 30 degrees. There's my conclusion. On your note sheet, put a capital P under that line, the red one, and a capital Q under the blue one. We would write this as P arrow Q. Now the truth value is this true? So if I said, guys, in my head, I'm thinking of an acute angle. Do you go, oh, it's got to be 30 degrees? And the answer to that is no. I might have been thinking of a 42-degree angle, or a 21-degree angle, or an 89.99-degree angle. I could have been thinking any angle under 90. It didn't have to be 30. So this would be called a false statement. And a counterexample would be what I just said. I'm thinking of 42 degrees, and that's an acute angle. Okay? I could say, if you are wearing red, then you're a girl. Any boy wearing red is going to go, counterexample. Okay, so it's one thing that proves the statement false. So let's talk about different types of subcategories of these conditional statements. And they are called the converse, the inverse, and the contrapositive. And you don't need to memorize these, again, unless you plan on not using a note card for your test. And I would have this sheet out while you're doing both your delta math, so it goes super fast, like honestly less than 5 minutes if you use your notes, and for when you're doing your worksheet. So here I have a conditional statement. A square is a shape with 4 sides. A square is a shape with 4 sides. I'm kind of talking about what a square is. I'm saying if a shape is a square, then it has 4 sides. When you see that word is, it goes forward. My dog is brown. If I'm looking at my dog, then it is brown. Okay, so let's go take a look. That word is, I just go straight forward. Draw an arrow under that. So if you see that on your worksheet, you know to go if a shape is a square, then it has 4 sides. It goes straight forward. The hypothesis is the shape being a square. The conclusion is it has 4 sides. This is true. And we'd write it as P implies Q. So the original is P arrow Q. Now converse, I like to call it the swapper. And you might want to write that word swap under there on your note card. So when you're doing your delta math and it says write the converse, you go, oh, I just need to swap the if and the then. So the blue will come first. If it has 4 sides, then a shape is a square. Now remember, for the symbols, we are using P and Q, but we just swapped them. So we swap them in our symbolic statement. We'd say Q arrow P because we swapped them. Let's talk about if that's true. If I'm thinking of a shape with 4 sides, must you conclude that it's a square? And that's false. Look at this trapezoid. It obviously has 4 sides. It's not a square. I could have put a rectangle up there or a rhombus. Okay, so next one up is the inverse. What an inverse does is it negates something. I like to call it the notter. I like to call them the swapper and the notter. What you do is you keep the original statement. That's really important. You don't go to your converse. You go back to your original statement up here, if a shape is a square, and all you do is insert the word not. If a shape is not a square, then it doesn't have 4 sides. We do that to the original. And again, if you need to pause to write these down, great. I don't know how fast you guys write. So all I did is take that original and put the word not in there. But as a mathematician, I would rather use symbols, and I need a symbol for the word not. And what that is a little squiggle. The reason P is coming first is because I went back to the original statement, if P then Q. And I negated it, so I put a little squiggle in front of it. Let's read it again and see about its truth value. If a shape is not a square, am I 100% sure that it doesn't have 4 sides? And I could tell you guys, everybody draw a shape that's not a square. I'm sure somebody would draw a triangle, somebody might draw a stop sign, an octagon, but I bet somebody draws a rectangle, or maybe even that trapezoid. So that is a false statement. Just because I know something's not a square Doesn't mean it for sure. Oh, I got an extra apostrophe in my doesn't. All right. Last up is our contrapositive. I call it the swap and notter. It does both with the original statement. So I'm going to swap and negate. So blue's going to come first with the word not in it. If a shape does not have 4 sides, then red with the word not in it, then it isn't a square. Now think of these symbols up here from the original. If I swap them, Q will come first. If I not them, I need the squiggles. So not Q implies not P. Let's read that. The shape does not have 4 sides, then it isn't a square. Well, that's very true. So the truth value of that would be true. All right. Lastly, write this on the back of your note card. We also have a symbol in algebra for not equal to, and it's an equal with a slash through it, kind of like a no smoking. You draw the smoking, you put a slash through it. So this says write the inverse of if 2x plus 1 equals 9, then x equals 4. Well, the inverse is the notter. I keep it in the same order, but I put the word not in it. But instead of writing if 2x plus 1 does not equal 9, then x does not equal 4, we use the symbols for it. So this would be the inverse of that algebraic statement. So that's it for your notes. Okay, so what's up next? Right now, you're going to use those notes to go do Delta Math for today in class. I'm going to check. It timestamps it. So I'll know if you did it in class. If you don't, you lose points. You have a full hour to get all of this done today. It looks like this. It says GeoPractice 2.2 928. Okay, and it's just 5 statements, and it's matching. Not matching, it's multiple choice. So it'll be like, which statement is the converse of if I am tired, then I sleep? You're going to look at your notes and go, oh, swap. And you're going to click on if I sleep, then I am tired. Okay, your assignment for today, which doesn't necessarily have to be done in class, but it'll be collected tomorrow, and you have enough time for it, is a modified worksheet. I cut it in half. Okay, so what if you didn't get it yesterday? It is in this folder, and you can just do it on a separate sheet of paper. What if you need help on it? There's help in the Help on Worksheets folder, so no excuses. All right, so have a good one. You should have just got 10 out of 10 on a test, hopefully, for just filling out the notes, which you'll show me tomorrow, and for answering the questions in the Ed puzzle, and then 5 homework points for your Delta Math. Excellent. Have a good one, guys. You're awesome.